Dear students, this is Java programming unit 3, and in this unit 3 there are totally three topics. One is known as first chapter is known as arrays, second chapter is known as inheritance, and the third chapter is known as interfaces. Okay. First one, arrays. Most probably most of these topics arrays are like in C, but there may be some difference, okay, in Java and in C. Now, first one, arrays. Arrays introduction. What is meant by array? An array is a group of like-type variables, same-type variables that are referred by a topic. And arrays in Java work differently than C and C++. And some of the important points about Java arrays. What are the different important points are? First one, in Java, all arrays are dynamically allocated. All arrays are dynamically allocated. Since arrays are objects in Java, arrays are objects in Java, we can find their length using the object property length. It is different from C and C++, where we find length using size. A Java array variable can also be declared like other variables with after the data type with some array representation after the data type. The variables in the array are ordered and each have an index beginning from 0. So always array index starts from 0. Java array can also be used as static local variable or method parameter. The size of an array must be specified by int or short value and not long value. The size of the array must be specified by int or short, but not long. The direct superclass of an array type is object. Superclass of array is object. Every array type implements the interfaces to one is clonable, and let me take about java.io.serializable. Second one, declaration and initialization of arrays. Declaration of single dimensional array. How we can declare type var name. So the example is nothing but int a of array. Initialization. How we can give the initialization type var name equal to list of arrays. Okay. So example is int a equal to 10, 20, 30, 40, 50. To allocate memory for one-dimensional array, we use new operator. How we can write a new operator? Type variable name array representation that equal to new type size. Type of size, that is int a of array equal to new int 3. That means totally how many values you can insert. A0 equal to 10, A1 equal to 20, A2 is equal to 30. Second one, declaration of two-dimensional arrays. How we can declare about two-dimensional array? The array is declared as follows. The syntax is type var name 2. Okay, array representation is 2. That is int a of 2 brackets, first one and second. Initialization of two-dimensional array. Array is initialized by type var name 2. Array, two array symbols equal to 2 braces. First braces okay, values comma values. How we can give the values 10, 20, comma 30, 40. 10, 20 is first row, 30 and 40 is second row. In first row, two values, that is 10, 20, and second row, the values are nothing but 30, 40. The array size is 2 by 2 because totally 4 values. To allocate memory for two-dimensional array, we use new operator. What is the general form? Type var name 2 brackets that equal to new type size, that is rows and size columns. Example is int a of 2 arrays 1 and 1, 2 brackets equal to new int 2 2. That means 2 rows and 2 columns. So A00 equal 10, A01 equal 20, A10 equal 30, A11 equal to 40. This can be okay, right. Next one, types of arrays or accessing elements of arrays. Suppose if the person is given types of arrays or how we can access the elements of arrays, we can write the same. What is meant by the array definition? An array is a group of same type of variables that are referred by a common name. Same type variable referred by a common name. One dimensional array. One dimensional array is a group of same type variables. It is represented by either x direction or y direction. In x direction, a0 is 10, a1 is 20, a2 is 30, a3 is 40, a4 is 50. Similarly, in y direction, a0 is 10, a1 is 20, a2 is 30, a3 is 40, and a4 is declaration. So how we can declare that is type var array int of array. Initialization is type var name list of values. What is the list of values here equal to 10, 20, 30, 40. To allocate memory for one dimensional array, we use new operator. How we can write type var name equal to types into f array equal to into 3. A0 is 10, taken a1 is 20, a2 is 30. Now accessing element. Accessing the third element. Third element is a of 2, that is 30. Now go for two-dimensional array. An array which is represented by two dimensions, x and y. One dimension is x, second dimension is y, two dimensions. It can be represented by x like this. That is a0, 0, 10, a0, 120, a1, 0, 30, a1, 40, b0, 0, 10, b0, 120, b0, 30, b1, 0, 40, b1, 150, b1, 260, b2, 0, 70, b2, 180, b2, 290. Declaration. The array is declared by type var name two arrays. Example is into a two brackets. Initialization. Array is initialized by as follows. Type var name two arrays equal to values comma comma. So we are given in x direction given about 10 comma 20. Sorry, in first row given the values are 10 comma 20. Second row given as 30 comma 40. Here you can see in first row given 10 comma 20, 30 comma 40. So the size is 2 by 2. In the two brackets equal to into x direction size is 2, y direction size is 2. So a0 is 10, a01 is 20, a10 is 30, a11 is 40. Therefore, accessing elements, second element means a01 that equal to 20. Second element, this is the second element. So a01 equal to 20. Now next one. Next one is multi-dimensional arrays. An array which is represented by 3 or more dimensions is called multi-dimensional arrays. It can be represented by first array representing each plane. For every plane consists of two dimensional. Okay, so it becomes about 3 dimension. In a plane that is single dimension, it values are index are 0, 1, 2. In 0, you can represent about 2 by 2 matrix, and in 1, 2 by 2, 2, 2 by 2. So therefore, it becomes about the 3 dimensions. Okay, so but 4 dimensions and 5 dimensions representations are very different. Declaration. There is declared as from type var name equal to 3 brackets, that means 3 dimensions. So example is int a of 3. The syntax is type var name 3 brackets, values. So here in first one 10, 15, 20, 25. In first one, what is the 10, 15, 20, 25. Second one 30, 35, 40, 45. Then third one, what is the 50, 55, 60, 65 can be represented by like this. Now next one, to allocate memory for 3-dimensional arrays, we use new operator. Now we can write new operator type var name 3 brackets equal to new type size. So here the size is taken as in first plane 3. In each one the size is 2 by 2. Okay, therefore 3, 2, 2 it comes. So a0, 0, 0, 10, a0, 0, 1, 15, a0, 1, 0, 20, a0, 1, 1, 25. How we can represent this one? First one 0, a0. So a0, this is 0, 0, a0, 0, a0, 0, 10. Next 0, a0, 1, 15, a0, 1, 1, 0, 20, a0, 1, 1, that is 25. Similarly here a1. So first index is nothing but the plane. Second one is nothing but the 2 by 2. Rows and columns. That is 2 dimension. Okay. So in first dimension it is a plane. That's why it is a first one is 0 here. Second one is 1 here. Third one is 2 here. Then for every one is nothing but 2 dimension. That means 2 rows, 2 columns. That means 0, 0, 0, 1, 1, 0, 1. But first 2 is nothing but plane. Now, for representing this, accessing the second element means a 0, 0, 1 that equal to 50. Alternative array declaration syntax. Now we can alternately declare this type bracket variable. Just you can write type bracket variable, that is int bracket space A. To allocate memory, then array var equal new type size, that is int bracket A equal to new int int. Now third one is storage of array in computer memory. In computer memory, how the arrays are going to be stored. The reference types in Java are stored in heap area. Is called as a heap area. Since arrays are reference types, that is, you can create them using the loop keyword. These are also stored by in heap area. So these are stored by heap area. See here, array with the primitive types. Here I am taking the stack area. So this is the heap area. So here array with primitive types int my array. What are the values? 25, 32, 56, 93. It is stored in heap area. It is stored in heap area. In addition to primitive data types, arrays also store reference types. Another arrays, multidimensional objects. In addition to primitive data types, okay, arrays also store reference types. Reference types. That is another arrays. Okay, objects. Another arrays objects. In this case, the object array multidimensional stores the references of the objects arrays. So, in addition to primitive data types, arrays also store reference types. Reference types means refer to another arrays. Reference to another arrays objects. Okay, that is known as multidimensional. In this case, the object either array or multidimensional, stores the references of the objects arrays, which points to the location of objects array. So array means objects, multidimensional means arrays. Like that. Array means can take about the objects, multidimensional means arrays. For suppose if we have a class with the name std with constructor that accepts the name of the student, and if we have defined an array of this class and populated is as shown below. Suppose if we have a class with the name std is a class is there with constructor that accepts the name of the student, and if we define an array of this class, then how we can store? Suppose a string here string. Okay, you are passing about the string. Then how we can store a my array? So here a my array that equal to new a. Then I'm taking about the a space my array, new a. My array 0 is nothing but Ravi, my array 1 is nothing but Raju, and my array 2 is nothing but so and so. Like that we can store. Okay. So this is the nothing but the storing about in the heap area. Storing in heap area. Okay. Again I'm repeating. Clearly understood. In addition to primitive data types, arrays also store reference types. Person by reference, it refers to another arrays, or it refers to objects. Either it refers to objects or it refers to another arrays. It may be multi-dimensional. Another arrays means either reference. What is the reference types? Reference types is array. Another array type. But another array is nothing but multi-dimensional. Or it refers another objects. In this case, the object array either are multidimensional. Array or multidimensional stores the references. So array stores about objects and multidimensional stores about arrays, which point to the location of objects and arrays. Objects are nothing but arrays are nothing but multidimensional. But suppose if we have a class with name std with constructor that accepts the name of a student, and if we have defined an array of this class, then how we can write? Suppose if you have a class with std, class is there with constructor that accepts the name of the student, and if we have defined an array, then how we can define? See here given. Okay. Suppose we are taking about the std with a. If you have a class with the name std, so this std class is taken here is a. Instead of std, I'm taking about the class is a with constructor. So a constructor that accepts the name of the student. So this is nothing but the accepting the name of the student. And if you have defined an array, then automatically how we can pass? We can pass a is Ravi, a is Raju, and a is Ram. Okay, the memory of the array, my array, how the memory is like this. My array So here object 1 is there, object 2 is there, object 3 is there. Object 1 is my array 0, that is nothing but Ravi. Object 2 is here I am taken new STD, but instead of STD here taken as A. Actually here in the diagram it represents about new STD, but in program it is representing about the A. That means okay, so A represents about STD. A represents about STD. Okay, A represents about STD. Now operations on array elements. Operations on array elements. The array copy method belongs to the system class. There is array copy. It is used to copy the contents of one array into another. The arrays class has two commonly used methods. One is copy of, second one is copy of range. Remember, array copy method belongs to the system class and it is used to copy the contents of one array into another. The array class has two commonly method, that is copy of and copy of range. That is the example here. Taken A is nothing but 5, 6, 7, 8, 9, 10. Now what I am doing here, arrays dot copy A comma 8. A comma 8. Total how many values? 8 values. But here how many values are there? 6 is there. So remaining 0 comma 0 it will take. Second one is a copy of range 0 to 5. 0 to 5 means how much? Up to 9. Up to 9. That's why up to 9 is going to be take. Second one. Okay, second one. Like that it's going to give the output. Now next one, assigning array to another array. One array, how we can assign into another. For that, better we take about first array. See here in this case, see here in this case, array in Java can be copied to another array using variable assignment. Variable assignment means equal to. Assignment means equal to. Okay, assignment equal to. This method has side effects. So by using equal to, so you can copy one into another, but it gives about some side effects. So to prevent these side effects, we use system.array copy method. Okay, array copy method. Side effect means sometimes changes is not proper. Okay, so change left side. If you change left side, for example, side effect. What is the exact side effect? Suppose you take x equal to 10. Now x equal to x plus 10. What is the value? Actually, you say that x equal to 10. But actually, x equal to x plus 10 means how much becomes x equal to 20. That means it's a side effect. So because of here, you can call as a side effect. That means by taking x equal to 10, but after some time, after substituting x equal to x plus 10, it becomes about 20. X equal to 20. That gives about some side effect. Like that, like that will come when we take about equal sign. That's why simply we can use about the system.array copy method. So array 1 is nothing but 1, 2, 3, 4, 5. Array 2 is nothing but 10, 20, 30, 40, 50. Now in array 1, so array copy, you take array 1 0. So starting from 0 and starting from 0 and it is array to 0 to 5. 0 to 5 means 10, 20, 30, 40, 50. You're going to be copy about 1, 2, 3, 4, 5 is copied to so instead of 10, 20, 30, 40, 50, it's going to copy it about 1, 2, 3, 4, 5. So the output is nothing but 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. After copying into array 2. You can write array 2 0 is 1, array 2 1 is nothing but 2, array 2 2 is nothing but 3, array 2 3 is nothing but 4, and array 2 4 is nothing but 5. Next. Next one, dynamic change of array size. How we can change dynamically changes. The dynamic array is a variable size list data structure. It grows automatically when we try to insert an element if there is no more space left for the new element. So if there is no space, it grows automatically. That is called as a dynamical change. So at runtime, it's going to be changed about its size. It allows us to add and remove the elements. So for this, it allocates memory by using heap. It can change its size during runtime. So for this, we use here vector. Vector is the easiest one. So vector is
Okay, you can use vector for dynamic array, which can grow or shrink its size. So just vector, this is a declaration, vector and string. Add first, second, third, fourth. We are adding to the this one. At runtime, we're going to add element rat, cat, and div. Then elements are nothing but actually we added about only up to this fourth. But at runtime, add element rat, add element cat, add element div. These three is going to be added at runtime. So automatically, it's going to increase the size. Now sorting of arrays. Bubble sort. Sorting here is taken as a bubble sort. Bubble sort is based on the idea of repeatedly comparing pairs of adjacent elements and then swapping their positions. The following figure shows the first pass of bubble sort. So here, this is the first pass of bubble sort. 5426 is compared and 26 is small, then it comes here 26, then it goes to 54 here. Again 54, 93 is compared, 93 is there, 54 is lesser, leave it. 93, 17 is compared, 17 is lesser, put here. 93, 77 compared, 77 is lesser, put here. Then 93, 31 is compared, 31 is lesser, put here. Now 33, 93, 44 is compared, 44 is lesser, put here. Then that is a swapping. Then 93, 55 is compared. Then 55 put here, 93 here. Now 93, 20 is compared. 20 here, 93. So finally 93 is the largest element. It's going to be put at the last place in first pass. Like that, there are different passes. From that, you can sort about all the elements. Bubbles are here. I'm taking the array. These are the different values. So you consider about two for loops. If AI is less than AJ, then both are going to be swapped. Finally, you can print about the sorted list. Okay. Now search for value in arrays. There are two types of searches here. One is called linear search. Second one is called binary search. What is linear search? First traverse the array. Match the key element with array element. If key element is found, return the index position. If key element is not found, then return -1. So class A, you consider about the method int linear. Method linear because in C you can write directly method, but in Java you cannot write about that. Compulsory write about it inside it because encapsulation is there. That's why you're going to be write compulsory in a class only. So a method cannot be write separately. Remember, int linear int A for a int comma key. So here for I equal 0, I less than a dot let I plus plus, it's going to be search. If AI equal to key, then return I. So otherwise return -1. If return -1 is there, return then element is not found. Return I is going to be returned. If AI and key value is equal to AI value, automatically it's going to return that I, that index value. So that's why we're going to be pass these values into key value. So A1 dot linear, here you are passing A2 comma key. A2 comma key you are passing A2 comma key, automatically it's going to pass and that value is going to be displayed here. Okay, that is where actually you are passing A2. That means array values are passed and key values also passed. A2 comma key. So after passing, then we are getting about return I means element is found. Return -1 is element is not found. Binary search. Second one is binary search. That is the comparison of binary search. Compare key with the middle element. If key matches with the middle element, we return the mid index. Else, if key is greater than the mid element, then key can only lie in the right half of the subarray after the mid element. So we repeat for the right half. Else, key is smaller, then repeat on the left half. Okay. So here I'm considering about the method is void binary. Then here int array, int first, int last, int key. First find out middle element. So while first is less than or equal to last, if a mid is less than key, then first equal to mid plus 1. A mid equal to key, then element is found. Else last equal to mid -1. Then you can find about mid equal to first plus last by 2. If first is greater than last, then element is not found. So here we're going to pass about these values here. Here consider about the array elements. These are the array elements. This is nothing but key, and find out last. Then A1 dot binary, you pass about A0 last and key. values are going to be founded, and from that element is found or element is not found, we will get it. Now, class arrays. Arrays also like a class. The arrays class in Java.wiki package is a part of the Java collection framework. This class provides static methods and dynamically create and access Java arrays. It consists of only static methods and methods of object class. The methods of this class can be used by the class name itself. The class hierarchy is as follows. That is Java language object, then Java.util arrays. Methods, binary search, compare, copy of range. All these are the methods in array class. Okay. Already know about what is meant by binary search. Compare. Both are going to compare copy of, it's going to be copy of range. Range values are going to be copied. Then next, arrays of varying length. That is increasing length. A jagged array is an array of arrays such that member arrays can be of different sizes. That is a two-dimensional array, but with a variable number of columns in each row. These types of arrays are also known as jagged array. Jagged array is suppose a two-dimensional is there. Two-dimensional is there. In that first row, second row, third row, fourth row, like the different rows is there. In this two dimension, the first row is taken in one array, single dimension. Second row is taken in one array, single dimension. Third row is taken in one array, single dimension. That means in two dimension, every row is taken in single dimension, then it is called as a jagged array. Again, I am repeating what is in the jagged array. The two dimensional array. Two dimensional array means there are different rows, first row, second row, third row, fourth row, like the different rows are. So, first row is taken separately in one array, a single dimensional array. Second row is taken in one single dimensional array. Third row is taken in one single dimensional array. Like that, if you take each and every row differently about single dimensional arrays, then it is called as a jagged array. Here two-dimensional array into two dimensions. A0 is I'm taking A0 is that means in first row there are three elements, single dimension. In A1, that is second row, taken about two elements. So here jagged array is created. That is the size is 2. That is first row and second row. The jagged array is created with first row and second row. In first row, that is A0, which is created about a single dimension, 3 elements. Second row A1, which is created about 2 elements. Then how we can get about the jagged array elements, that is first row elements and second row elements, means for I int I equal 0, that is rows, then first row, second row, third row for this one. Then for every row you need about the different elements for this one. Then you can print about ij. Okay, so like that. That means simply here for two dimension we have taken each row is separately in single dimension. That's all. Each row in a two dimension is taken about separately about the single dimension. That is only the point here. So for this, what it represents number of rows, first row, second row, third row. For every row, it represents about different elements, first row elements, second row elements, third row elements. So from this, you can print about the first row elements, second row elements like that. This is called as a jagged array. Then arrays as vectors. How we can represent about the arrays like vectors? The vector class implements a global array of objects. That means always it will be the runtime. At runtime it can change about its size. So vectors basically fall in various classes, but now it is fully compatible with collections. It is found in Java.util package and implements the list interface. So we can use all the methods of list interface. Vector is like the dynamic array, which can grow or shrink its size. Already we discussed about this type of program previously. Now next one is inheritance. Next concept is inheritance. Introduction or process of inheritance. What is meant by inheritance? A class is derived from another class is called inheritance. If class B is derived from class A, then B is called subclass and A is called superclass. The subclass can have its own properties and superclass properties. Without writing the superclass numbers in subclass, we can refer the superclass numbers in subclass. This is known as reusability. That means superclass is there. Okay. Without writing the superclass elements numbers in subclass, That means superclass data we are not writing in subclass, but we are referring directly about the superclass methods. Okay. So without writing the superclass data in subclass, directly we are referring about the superclass elements. That is called reusability. So in one class elements, we are not writing in another class, but directly we are referring about that one. That is called as reusability. If we create superclass object, we can refer only superclass numbers. If we create subclass object, we can refer subclass numbers and also superclass. Inheritance is achieved by extends keyword. A subclass can be a superclass for another subclass. Syntax means class A, class B extends A. Is code here for constructor method and inheritance. See, actually, here how we can write about the constructor method in inheritance. Constructor in inheritance. How we can write constructor method? That means constructor in inheritance. Here, when we create object B, it calls B's constructor and also A's constructor. That means class A, we are taking about A constructor. Now its inheritance, that is class B extends A, B constructor. Now, what is the advantage here? Suppose if you call class B constructor, if you create the object for B, automatically it calls about the B constructor and also A's constructor. Then types of inheritance. There are different types of inheritance. Single inheritance. What is single inheritance? If only one subclass is derived from only one superclass, then it is called single inheritance. For example, if A is superclass, then subclass B is derived from A. So example is nothing but class A, then A's constructor, class B, B's constructor. Then single demo. Here we are creating the object for B. This is nothing but the syntax. Similarly, we are having about the multi-level inheritance. What is multi-level inheritance? If a subclass is derived from a derived subclass. If a subclass is derived from a derived subclass, then it is called multiple inheritance. Here B is derived subclass. For example, if A is superclass, then B is derived from A. Again, C is derived from B. Example. How you can write the example here? Example, class A constructor, class B is B constructor. Now class C extends B. So B is A, B extends A, C extends B. That means if you create object for C, automatically calls about B's constructor and also A's constructor. Now this is the right side is nothing but its syntax. Now next one is nothing but the hierarchical inheritance. If more than one subclass is derived from only one superclass, then it is called hierarchical inheritance. Hierarchical inheritance contains one superclass and more than one subclasses. For example, if A is superclass, then subclass B, C are derived from A. So here also you can write like this: A constructor, B's constructor, C constructor, then B and C you have to create the objects. Multiple inheritance. If only one subclass is derived from more than one superclass, then it is called multiple inheritance. So multiple inheritance contains one subclass, more than one superclass. Multiple inheritance cannot be possible using classes, but it can be possible using interfaces. So first we can consider about the two interface A, interface B. Now interface C extends A comma B. That is called as multiple inheritance. Now this C interface can be implemented in a class. That means example is this one: interface void display, interface B void show, interface C extends A comma void column. Then these three methods you can write here. Then automatically you can call about these methods. Okay, universal superclass, that is object class. Universal superclass is also called as a object class. That is superclass for all classes. Superclass for all classes, which we can call as universal superclass. In Java, all classes is inherited. If the superclass is not specified, then all classes are derived from object class. So object is a universal superclass. The general form is a class example extends object. Object class is a superclass and all classes are subclasses of object class. In object hierarchy, object is a superclass and different subclasses are boolean, character, number, string, etc. A class which can use as data type and also as predefined class, then that class is called wrapper class. So a class which can use as data type and also predefined class. So suppose a class which is as a predefined class and also data type, then it is called as a wrapper class. Boolean, character, byte, short, integer, long, they are called as they call as wrapper class because they use as both data type and also predefined classes. All mathematical functions are represented in that class. The object hierarchy is shown below. Here you can see about the object header. Object is a superclass for all classes. Boolean character number, string, buffer, thread group system, runtime security manager, class loader. Throwable is error and exception. Main thread is object. Then again number is the byte short integer long float and flip. Then there are it consists of some of the methods also here given. Object clone boolean equals void finalize class get class int hash code void notify on string void wait long sequence all are nothing but the different methods inhibiting inheritance of class using final. That means how we can use the final keyword. The final keyword is used for variables, methods, and also classes. If you use final keyword to a variable, then that variable cannot be changed. It consists of using final to prevent override. Here, final void display you are writing. Void display before you are writing final. Again, in subclass you are writing the void display. That means this void display cannot be rewritten in class B. That means it cannot be overridden. So there is a problem. So in the above program, we use final before void display method. Then that method cannot be overridden. Then using final to prevent inheritance. That means if you write final class A, that is for one class, if you write a final class A, then that class cannot be extended. That means it cannot be inherited. Then using final to a variable. So before variable, write a final keyword, and that variable cannot be changed. For example, here final int L equal 10. So after some time, if you write L equal 20, what it gives, it cannot take about L equal 20. Always it is L equal to 10 only. Then next access control. Next one is known as about the access control. Access control. The different Java's access specifiers are. So in access control and its inheritance, you can specify about the different specifiers: public, private, protected, and friendly or default. If a class is visible to all classes, then public is visible. If a class is visible to only that class, even it is not visible to its subclass, then private is visible. If a class is visible to all classes and its subclasses in same packet, but visible to subclasses in other packet, then protected is visible. If a class is visible to all classes and its subclasses in same packet, but not visible to other packets, then friendly or default is visible. So let us understand the access modifiers in Java by a simple table. See here given about simple table. Access modifier private default protected public. Within class yes, private. Within package no. Outside package no. Outside package default. Within class is yes. Within package is yes. But outside package is no. Outside package is no. Protected yes. Within package yes. Outside package yes. By subclass. Outside package no. Public all are yes. Application of keyword super. Application of keyword super. That means how we can use this super keyword. If a subclass needs to refer its immediate superclass, then we use super keyword. It is two forms. First form, the super keyword call the immediate superclass constructor. Syntax super parameter list. In second form, the super keyword can access the immediate superclass members. That means you can use for super dot member. Member can be immediate superclass data and methods. For data also you can write the super. For methods also you can write about this. First one is you can use for immediate superclass constructor. Second one is to access immediate superclass members using super to call superclass constructor without parameters. That means A without parameters here. In B, just write super. That's all. It's going to be called about the superclass, immediate superclass constructor. Then into volume, you write about the function method. Then you can write about the program. Similarly, that is a main function. Similarly, superclass to call superclass constructor with parameters. That means in constructor, write u into u into v. That means L equal to u and v equal to v at the top. Now into H, now super u comma v, you have to call about super u comma v means it's going to be called about this. Then H equal to. Suppose into L comma b. Suppose if you write about the instead of int u comma int v, if you write same int l comma int v, then automatically what happened means this is called as a local variable, this is called as a class variables. So local variable can hide about the class variables. At that time, we can use about the this operator. This dot l equal to l, this dot b equal to b. This key. Okay. So when local variable and class variable, in class we are writing some variables. Okay, that variables, class variables, and in local variables, if both are same, then automatically it's going to be hidden to about into this one. This is going to be hidden. Okay, this value will come up going to be hidden. So to refer that hidden values, then what you can write, this dot l equal to l, this dot b equal to b. Then next one is so here we are writing about two parameters into u comma into v. So to call this in u comma into v, you are writing super u comma v. This is called as a super with parameters. Then remaining is same. Here you pass about the values. The second usage of super keyword referring superclass data. Suppose if you write int l equal to 10 here, again it l equal to 20 here, then what happened? You cannot call l equal to 10 here. So because this L is going to be hide about this L, okay, this class L is going to be hided about this class L. So to refer this one separately, then you can write super dot L. So that means we are using super for immediate super class variables. Similarly, method. Similarly, suppose here you write void display one method. Same method if you write here, then to refer this void display, to call this void display, here you write super dot display. Okay, then only you can call this display inside this. Otherwise, this void display is going to be hidden about this void display. That means one more thing here, definition. If a method in superclass and subclass have the same signature, that is both are same, then that method name, that is what is signature, method name, type of parameters and return type, all are same. Then the subclass method override the superclass method. The subclass method can override the superclass method. So this is called method overriding. This is known as method override. Okay. So actually here we are writing void display here. Same method we are writing here. Then what happened? This method going to be hide about this method. So to call this method, what we are writing in this method, we are writing super dot display. That is referring super with super class number methods. Then next method overriding. Again, same thing here I written. Same writing here, written here. Then next dynamic method dispatch. Dynamic method dispatch means which overriding method is called can be decided at runtime. Actually, in method call it can be decided compile time, but overriding methods, which overriding method is called can be decided at runtime, not at compile time. It's called dynamic method dispatch. Using a superclass object reference, we can decide which overriding method can be called. Example program. See here, void display writing inside a class. Again here same. That means this is called as a overriding. Similarly, here also writing about the same. So in this case, that is in this overriding, which overriding method is called, which overriding method is called can be decided by some reference. Okay, which overriding method is called, okay, decided at runtime. That is called as a dynamic method dispatch. So here at runtime, what I am doing is I'm just putting about object creations of these three. Now take A is reference. This reference is C1, then you can call about C1. Reference is B1, then you can call B1. Reference is A1, then you can call this. So this reference REF reference is going to be created for A. That is called as a dynamic method. So which method is called can be decided by A reference. A reference. Okay. Which method is called can be decided by A reference, which we can call as a dynamic method dispatch. Okay. Suppose if reference equals C1, then if you write the display, then it will call about C. Reference equal to B1, or the reference dot display means it will call about B1. Then reference equal to A1, that means the reference dot display means it will call about A1. This is called as a dynamic method dispatch. Abstract class. If the object of a class cannot be created directly, if the object of a class cannot be created directly, then it is called abstract class. Okay. in abstract class, at least one method can be abstract. Suppose if in abstract there are so many methods are there, at least one method should be abstract. The abstract method can be declared in abstract class only and defined in subclass only. We cannot declare abstract constructors or abstract static methods. There is no abstract constructor, there is no abstract static methods. Abstract class A here, abstract void display, one method. So this method is going to be declared here because there is no braces. Here it's going to be defined. Okay, that is in class B. By creating object B, we can call about this void display. Interfaces and inheritance. Interfaces and inheritance. Interfaces are like classes, but unlike classes, it contains method declarations but not definitions. So in interfaces, only method declarations is there, not definitions is there. Definition means braces. So for method, there is no braces. Okay, just declaration only. In interface, we declare methods and final variables. Variables are called final. We can inherit the interface for multiple inheritance. So in inheritance, how you can use interfaces in inheritance means for multiple inheritance you can use. Now interfaces, introduction. So interfaces are like classes, but unlike classes, it contains method declarations, not definitions. In interface, we declare methods and final variables. Declaration of interface. See general form. So you can write access interface, access, then interface. Access means public, private, protected. Interface, then interface name. Final type variable value, then type method. Then an example is interface A. So here access is nothing but access is either public or not used. Either you can use public or you can no need to use it. Variables. Variables are always final. So that's why final int L equal 10, 20. L equal to int L equal 10. Int L equal to 10, B equal 20. But the actual mistake is there here. B equal 20. Just L equal 10, 20 is wrong. Here you can write about B equal to 20. Then next, implementation of interface. For implementation, access class name, extend superclass. So minimum you can write access class name. That is minimum. Okay. So extend superclass is optional. Implements interface is also optional. That means here compulsory you have to use access is either public or not used. Here also access means either you can use public or not used. The interface methods which are defined in a class should be declared as public. The interface method which are defined in a class should be declared as public. This compulsory public. That means interface A void display everything. But for this void display compulsory have to use public here whenever you go to implement in class B. Otherwise it gives about the wrong. Then finally next you can create object for B and call for B1.display. Interface versus abstract class. What is the difference between interface and abstract class? Interface. An interface contains all method declarations. That means all methods are abstract. In interface, it is compulsory to implement the interface in class using implements keyword. We can implement multiple inheritance using interface. We can use extends keyword for interface also. Abstract class. An abstract class contains at least one method declaration. At least one method should be abstract. In abstract class, it is compulsory to extend the class using extends keyword. We cannot implement multiple inheritance using class by class. We can use extends keyword for classes also. Then next, interface versus class. What is the difference between interface and class? Interface. An interface contains all method declarations. In interface, all variables are final. In interface, it is compulsory to implement the interface in classes using implements keyword. We can implement multiple inheritance using an interface. We can use extends keyword for interface also. Class. Class contains method definitions. In class, it is not compulsory to declare final variables. Okay. In classes, it is not compulsory to extend the classes using extend keyword. It's not compulsory. We cannot implement multiple inheritance using class. We can use extends keyword for classes. There is a difference. Multiple inheritance or inheritance of interfaces. Inheritance of interfaces or multiple interfaces. An interface contains variables and methods like a class, but the methods in an interface are abstract by default, unlike class. Multiple inheritance by interface occurs if a class implements multiple interfaces, or also if an interface itself extends multiple interfaces. Remember, an interface contains variables and methods like a class. An interface contains variables and methods like a class, but the methods in an interface are abstract by default, unlike a class. Multiple inheritance by interface occurs if a class implements multiple interfaces. So multiple inheritance by interface occurs if a class implements multiple interface or if an interface extends multiple interfaces. So multiple inheritance, how you can provide by interface occurs if a class implements multiple interfaces. That means you have multiple inheritance by interface. How it going to be occur? That means the interface occurs means if a class implements multiple interfaces. That means there is interface A, interface B. If class A implements, interface A is there, interface B is there. Then class C is there. So class C implements A comma in this one way. Another way is interface A is there, interface B is there. Interface C extends A comma. Then it is called as a multiple interface. Multiple interfaces. Multiple interface or inheritance of interfaces. Multiple interface or inheritance of interfaces. That means suppose there is a class is there, B, A interface there, B interface there. Then class C implements A comma B. That's one way. Or interface A is there, interface B is there. Interface C extends A comma B. Both are same. A program that demonstrates multiple inheritance by interface in Java is first you write interface A, void display interface B, void call me interface C extends A comma B. This is called as a multiple inheritance. This is called as a multiple inheritance. Class D implements C. Now we write about the public void display, public void show, public void call me. Then multiple demo, you call about that one. Nested interface. What is between nested interfaces? An interface inside another interface. An interface inside another interface is called nested interface. The example program is given by interface A, void display. This is about interface. So in interface A, again you are defining interface B, void call me. Now you write for void display method and void call me method in class C. Now create the object for C, call that both methods. Now next one, default methods in interfaces. Very, very important. Default methods. What is meant by default method? Java 8 introduces the default method or default methods features which allows the developer to add new methods to the interfaces without breaking their existing implementation. Without breaking the existing implementation, you can add the new methods. That is called as a default methods in interface. Syntax is public interface vehicle. So default. The default method I'm writing about void print system.out.println. I am a vehicle. With the default functions in interfaces, there's possibility that a class is implementing two interfaces with the same default methods. So here with the default functions in interfaces, there's possibility that a class is implementing two interfaces with the same default methods. You can also write about the same default methods. You can also write about the same default methods. See here, public interface vehicle, public interface four-wheeler. Here default void print is there. Here default void print is there. Okay, same method. So with the default functions in interfaces, this is the default function, this is the default function. So default function interface, it is possibility that a class implementing two interfaces with the same default methods. Two interface with the same default methods. Next one is static methods in interfaces. Static methods in interface are those methods which are defined in interface with the keyword static. Unlike other methods in interface, the static methods contain the complete definition of the function. And since the definition is complete and the method is static, therefore these methods cannot be overridden or changed. Remember, static methods interface. Static methods interface are those methods which are defined in interface with the keyword static. So in interface, if you write the keyword static before method, then it is called as a static methods in interface. Unlike other methods in interface, these static methods contain the complete definition of the function. That means see here interface A. Previously, how you can write void display string str, but if it is static, complete definition you have to write. That is the difference. Complete definition you have to write. That is the static. So all static functions or all static methods compulsory you have to write about the complete definition. Without static means you have to write void display. Then this display you can extend here. The display you can extend here. Okay. Then static demo, then BB1, then you can call about the hello and display. Then functional interface. What is meant by functional interfaces? A functional interface is an interface that contains only one abstract method. They can have only one functionality. From Java 8 onwards, lambda expressions can be used to represent the instance of a functional interface. The functional interface can be have any number of default methods. Runnable, action listener, comparable are some of the examples of functional interfaces. Here I am using about the runnable. Here I am using about the runnable. So class functional demo public static void by new thread new runnable. This gives about one of the functional interface. Now, next one is annotations. What is meant by annotations? Java annotation is a kind of a tag that represents the metadata or information attached to the class. Something is going to be attached for a class that is called as a Java annotation. Class, interface, methods are filled to show some additional information. So you're going to be attach some additional information that we can call as annotation. That Java compiler JVM can use. That additional information which is going to be attached that can be used by Java compiler and JVM. Though annotations are not a part of the Java code, they allow us to add metadata information into our source code, which we can call as a metadata. Java introduces annotations from JDK file. There is no direct effect of annotations on the operation of the code they annotate. They do not affect the execution of the program also. Annotations provide supplemental information, which we can call about a program. Some points about annotations are they start with the text symbol. They do not change the action or execution of a compiled program. Annotations help to associate metadata information to the elements, like comments, but it is not comment exactly, like classes, instance variables, constructors, methods, etc. We cannot consider annotations as pure comments, remember, as they can change the way of a compiler treats a program. Sometimes it can be considered. Okay, it is not completely about the comment. Example is I'm defining about the class A void display. Class B extends A. Here it's going to be overridden void display, right written. Then annotate demo, then creating object and call it. Just is override gives about the annotation. That is the additional information. What is the additional information here? At override is called as a additional information. Okay, additional information. Okay, this is going to be completed about the third unit, very simple unit. You can easily prepare within 1 hour. Okay, 1 or 2 hours hardly. Thank you.